Okay, we're going to talk about forms of a quadratic equation. So you've got standard form, ax squared plus bx plus c. The only information you can really get from this by looking at it is you can get your y-intercept, that's your c value. Your axis of symmetry is going to be your vux. If you want to find your axis of symmetry, type this into y equals and then find your vertex point. It's the easiest way to do that. Vertex form, this is when you can see your vertex point by simply looking at the equation. Remember h, when you remove it from the inside, it's going to be the opposite. So whatever its sign is inside the parentheses, that's the opposite sign here in the vertex point. And then k is the exact same since it's an over number. It's outside. Your axis of symmetry is going to be the x value of your vertex point once you write your vertex point. You could also always type this into y equals and use your calculator to find the vertex, which is what I recommend. Factored form. So this is when you're going to see two sets of parentheses. What you can get from the parentheses is that you can set them equal to 0 and solve for x so that you can get your x-intercepts. Personally, if you have a y equals equation, type it into y equals and then use your calculator to find your x-intercepts, just like I showed you on the last video. And then your axis of symmetry, again, just like with standard form, find the vertex using your calculator, and then your axis of symmetry is the x value of your vertex, and it's a vux line. Okay, converting from vertex to standard form. So if it's a multiple choice, the best way and the fastest way to solve it is to type f of x into y1. That would be the problem, the equation you get in your problem. Then type your answer choice into y2 with your darker line. So you want it to be a darker line, okay, so that you can see the two equations, and hit graph. What you're looking for is you're looking for y2 to overlap completely with y1. If they don't overlap, they're not the same equation, which is why you're not seeing the same graph picture. But if you want to work it out by hand, you certainly may. First thing you're going to want to do is the box method. So I've already set it up here for x plus 1, so we're very quickly going to fill these in. So filled in our boxes and combine like terms, so we would combine these, and that would give me 2x, so it's going to be x squared plus 2x plus 1. And now we're going to distribute the a. So that would be negative 3x squared. Negative 3 times 2x is going to be negative 6x. And then negative 3 times 1 is going to be negative 3. And then we bring down that minus 2 at the end. And then we've got to combine like terms. And the only terms that we can combine are the two constants at the end. So when I combine a negative 3 and a negative 2, I'm going to get f of x is equal to negative 3x squared minus 6x minus 5. Now, if this were a problem and it was multiple choice, this would be what I would type into y1. And then if this was my first answer choice A, I would type it into y2, and then I would push my left arrow key back to make it a thicker line, which I'll do very quickly. Negative 3x plus 1 squared minus 2. And then this would be my answer choice. My first answer choice I would type in negative 3x squared minus 6x minus 5. And then I would arrow back to the left to change this thin line to a thick line. And all I have to do is hit enter once. And now I'm going to hit graph. And I want to see an overlap. So there's y1. There's my problem. And then you can see y2 graphs directly over it. So I know I have converted to standard form correctly. If it didn't overlap, then I would mark this answer choice out, and I would go back to y equals, and I would clear out y2, and I would type in my second answer choice, and then hit graph. I'm looking for that overlap. All right, writing equations in the calculator. So what you want, here's what you're going to do the same thing here. You're going to type in your two answer choices, or you're going to type your equation into y equals. You're going to check your vertex point. So you have to go second trace, okay, and find your vertex point and see if it matches what they say the vertex is supposed to be. Then you have to check the other point in the table, okay? And that is what I would do. If they give you a graph, here's what you can do. You can 3 points. So negative 1, 0. I've got 1, negative 4. And then I've got 3, 0. Again, type these into your stat enter. Negative 1, 1, 3. And I've got 0, -4, 0. Stat over. Option 5 for quadratic. Oops, sorry. And then I've got A equals, B equals, C equals. So 1, -2, -3, which is going to be y equals x squared minus 2x minus 3. If once you get your equation, then you can type it in to y equals x squared minus 2x minus 3. Graph it. You can check your vertex to see if it is 1, -4. This is supposed to be a minimum, so I'm going to pick option 3. I'm going to move my cursor to my vertex as close to it as I can get, and then I'm going to go to left of that. And then I'm going to go to the right side of the vertex point, lock in, and 1, -4. So that is correct. I can go to my table and check. Does it have the point -1, 0? Yes. Does it have the point 3, 0? Yes. So I have verified in my calculator that these points, this equation, does create that graph. All right, factors. Here's how factors work. If you ever have to match it up, two equations, one in factor form, one in not, I would graph both of them in y equals and see if you get overlapping graphs. Okay, here's how factors and your quadratics match up. If you have a solution, you can turn it into a factor by making 0 on one side. So I would move this 3 back over here, and when I move it to the other side, I have to change the sign. So it would be x and then -3, because that 3 is going to become negative. But the thing with factors is you've got to have 2. So if they tell you only have one solution, that tells you that you have 2 factors, but they're the exact same. That's why you're only getting one solution, because when I set this equal to 0 and solve, x equals 3 shows up twice. It's the same solution. We're only writing it once. Okay? Same for here. My linear factors are x equals -3, x equals -1. So if I want to write this as a quadratic equation, I'm going to write it in 2 parentheses in factor form. But here's what I'm doing. I'm going to move this -3 back to the other side with the x. And when I move a -3, it's going to change to +3. So I'm going to have x plus 3 as a factor, but its solution is x equals -3. For here, how can I rearrange this so that I get the x and -1 on the same side? Well, simple. I move my -1 to be back with the x. That creates my factor, and I've got x plus 1. So remember how we did inside the parentheses? It's always the opposite. Well, what's the opposite of a -3? +3. What's the opposite of a -1? +1. Okay? So it's kind of keeping that same trend or pattern. So hopefully this helped you match up quadratic equations.